In this lecture, we will see how we can also combine multiple instances of our element widget. The overall app structure remains unchanged. In this example, the focus is on the child of the center widget, which is now a column, so a row would work just as well. The column contains 3 identical element widgets, all created using their default parameter values. As a result, the 3 rectangles have the same size and color. The center widget horizontally centers the entire column within the screen, but the column itself expands vertically to take up as much height as it can. This means that, by default, the 3 elements are stacked from top to bottom and may appear aligned toward the top of the screen if they don't fill the full height. If the device is rotated, reducing vertical space, the gap below the elements would naturally shrink. To gain finer control over how the items are aligned and spaced inside a column or row, we need to introduce additional layout widgets. To improve widget positioning, we need to understand 2 key layout concepts: the main axis and the cross axis. In a row, the main axis runs horizontally, while the cross axis runs vertically. In contrast, a column reverses these roles. The main axis is vertical and the cross axis is horizontal. When working with a column or row, we can start by setting the main axis size, which defines how much space the widget occupies along its main axis. This can be set to min, meaning the widget only takes up as much space as its children need, or max, allowing it to expand and fill the available space horizontally for a row and vertically for a column. Next, we use the main axis alignment property to control how children are arranged along the main axis. For instance, start aligns them at the beginning, center places them in the middle, space between distributes equal space between items, and space around adds equal space around each child, causing the space between items to be twice as large as the space at the edges. This gives us fine control over distribution, but the actual layout adapts automatically to screen size and orientation. In a similar way, we can align children along the cross-axis using the cross-axis alignment property. This controls their position perpendicular to the main axis and includes options like start, end, and center. With so many layout options available, choosing the right editor becomes especially valuable. Using Visual Studio Code with the proper Flutter extensions makes configuring widget properties like alignment much simpler. By selecting the widget directly, you can access intuitive drop-down menus and context-aware suggestions to adjust the settings. This means there is no need to memorize every property or frequently consult the documentation. It also makes it easy to view and change default values on the fly. We have already used the Colors class. It offers a broad selection of predefined color swatches, simplifying the use of colors without having to define them manually. Each swatch can be accessed by its name, for example, colors.blue, or customized by specifying an intensity in square brackets. Values from 50 to 400 produce lighter versions of the color, while 500 is the default base color. Values ranging from 600 to 900 give progressively darker tones. As we will explore soon, this isn't the only way to define and use colors in Flutter, but it's often the easiest and most readable method. Let's revisit the example we have already explored. This time, the child of the center widget is a row containing 3 element widgets, each initialized with custom parameter values, where the defaults don't fit. The first element has a custom 8, the second element has a custom color, and the third both a custom 8 and color. We apply main axis alignment dot space around to distribute the elements along the main axis, horizontal, which means there is equal space around each element. Consequently, the space between elements is twice the space between the elements and the edges of the device, even though no explicit spacing values are set. For the cross-axis vertical, we use cross-axis alignment.center, so all elements align vertically relative to the center of the row. The different eights of each element visually demonstrate how vertical alignment behaves when child widgets vary in size. Widgets are not only stateless, and now we need to learn how to create stateful elements.